Okay, so we are starting on Chapter 7, and Chapter 7 starts getting into arrays. Now, arrays are kind of different. What I want you to think of an array as is think of your array as an ice cube tray. So, the ice cube tray is the object, okay? And it's going to hold different little ice cubes in it. So what we need to do is take that ice cube tray and declare it as a data type. It can be any data type, it can be primitives, or it can be a string. So once we get that initialized, what we need to do then is tell how many individual ice cubes are going to be there. And we're going to call those ice cubes elements. Okay. Now, we're going to have what's called a substring, and so that think of each of those ice cubes being numbered, and that number is going to be what's called the subscript. So if I have an ice cube tray, I'm going to call it students, and I'm going to have the ID of each student in there, and let's say it's going to be an integer. So I could actually say student number 3 is basically equal to this. So we're going to go to that. Now, this is where it gets kind of different. All subscripts start with 0. So if I say student number 3, that's actually going to be student number 4. 0, 1, 2, 3. So let's take a look at the array demo number 1 on page 410. And if we look in here, we basically have, first we declare a final int. So we have a constant integer called employees, and it's 3. So you notice right here, this is where it gets different. I've got int left square bracket, right square bracket, and then I'm giving it a variable name of hours, and then I'm initializing it as a new int employees. Okay, so the employees is what? That's the constant number 3. So what I'm telling it is I want to declare this with 3 elements of this array. Okay. Now you'll notice we've got the left and right square brackets here in front of the int. I can actually put those behind the hours as well. So I could actually put my left and square brackets there as well. They're interchangeable. It doesn't matter. So what I'm telling it is, whenever we see this left and square bracket, I'm telling it that this is an array. At this point, I don't know how many elements are in it until I get over here, until I instantiate it as a new array, and I'm telling it how many elements are going to be in there. We're going to basically get information from the console, so we're using the scanner keyboard, and I'm saying enter the hours worked by. Now, it says employees. What is employees? That's the constant 3. So it's going to say enter the hours worked by 3 employees. So sysout print employee 1 hours 0 equals some integer amount we type in. And then I get the next one, which is number 1. So the number 1 element, the number 2 element. Now notice I have 3 as the number of elements in the array, but notice I've go 0, 1, 2. So we're going to see how we need to kind of deal with that. Make sure we always keep that in the back of your mind, that even though it says we have 3 elements, the highest number is going to be 2. And then we come in and say print the hours entered are hours 0, hours 1, hours 2. So again, in this case, the word hours is our ice cube tray, and we're looking at the very first ice cube, the second ice cube, and the third ice cube. Okay, so if we go ahead and run this, and it says enter the hours worked by employee number 1, we're going to say you worked 36. Second one, we're going to say they worked 38, and the last one we're going to say they worked 40. So the hours you entered are 36, 38, and 40. So again, hours is the ice cube tray. It holds data, and each individual little ice cube formation is going to hold basically data. Now everything inside that ice cube tray has to be the same exact data type. I can't put strings, I can't put integers, I can't put doubles. If I declare that ice cube tray as a double, they all have to be doubles. If I declare it as a string, they all have to be strings. If I declare it as an integer, they all have to be integers. Now realize, if I do need to convert it, I can use the parse and I can convert an integer to a double and vice versa, or string, whatever the case may be. So that's the basis of an array and how we create them. And it goes on to the next section and talks about, well, let's just take a look at it. So we got array demo 2. So here we're basically going to use loops in this case. So we've got an array, and now we're going to use the looping feature. So same exact thing, int employees number so we got a constant 3. We declare our array hours as an integer data type, and it's going to have 3 because there's our constant 3. And again, we use a scanner keyboard and enter the hours worked by the 3 employees. Now this time it's basically going to do a for loop. So for int, so we're going to create an index as an integer data type, and we're going to set it to 0. And then while the index is less than employees, in this case it's 3, I'm going to go ahead and increase it by 1 each time we go through here. Now notice it says less than employees. That means if it's a 3 that's equal to employees, we will basically drop out. So we come in, we say employee index plus 1. Now why are we doing that? Well, we're trying to say what number employee this is. We don't want to say 0. We don't want to have our employees starting at 0. So we add 1 to that subscript, and so it will display employee 1, and then we display their information. So we're saying what is the hours for employee 1, and the hours and the index. Okay, we're going to basically say what ice cube in that tray are we going to put this in. Well, first time through it's a 0. And we basically what we get from the keyboard. We come back through, we increase our index by 1, so index is now a 1. Now we display it as employee 2 because we add 1 to it. And our hours index is a 1, and whatever we type in the keyboard now goes in that ice cube slot. Okay, so 0, now we're at 1. We go through it one more time, we're now at ice cube slot number 2. This time we're going to call it employee number 3. We put it in there. So then we say the hours entered are, and we do another for loop exactly the same way. int index equals 0, index is less than employees, increase it by 1 each time we go through. We basically print the hours and the index. Okay. So we could actually, well, let's run this first. We're going to get the same exact situation. So I go ahead and run this. And if I type in 36, 38, and 40, I get the same exact thing. But again, what I could do though is down here I could say employee. I could do the same exact thing I did up here. I'm going to copy and paste this right here. So I'm going to say employee. I want it to say what number employee this is. Again, so the first time through, index is a 0, but I don't want to display 0. I want to show employee number 1, employee number 2, employee number 3. So to get around that, I add 1 to the index each time. So now when I run this, I type in 36, 38, and 40. And it says hours you entered are employee 1, 36, employee 2, 38, employee 3, 40. Again, first time through the index was a 0, we added 1 to it, so it displays 1. Next time through it would have displayed a number 1, but we added 1 to it, so it displays a 2. And same way for the third one, it's a 2, we add 1 to it, so it displays 3. So realize that the arrays always start at 0 and work up from that. We're going to see month here in a second. We're going to create a month array, and the thing about a month array is if we wanted to use that number, if we want January to be 1, guess what we have to do? We need to add 1 to that index. Now we do the one thing that we need to make sure we always do is we need to stay within our boundaries. And what do I mean by that? Well, when we're dealing with arrays, we need to make sure that if I've got 5 elements in my array, I can't go higher than the number 4. Because remember, we start at 0. So we always have to make sure we stay within the bounds of that array. And that's kind of what the next one is basically dealing with. It's called the invalid subscript. So here's what we're doing. I'm creating an array called values, and it's an int data type, an integer data type, and it's going to have 3 elements, 0, 1, and 2. I will attempt to store 4 numbers in this 3 element array. So I'm saying 4, so I'm creating a new integer, call it index, initialize it to 0, and while it's less than 4, that means it's going to try to go to the number 3, and I'm going to increase the index by 1 each time I go through. So I got system.print now processing element, and here's the index and the value and the index. So it's going to take whatever we type into values and display 10. Okay. So what it's going to try to set each element to the number 10. We're going to get an error here. So if I run this right here, this is what's called the invalid subscript. Whenever you see that, we can pretty much guesstimate that we tried to go above and beyond what the array could handle. So what it's showing here is, this is, see the number 3? That says that's the subscript we are currently on. We can't go above that. Okay, or I should say we can't go. That's incorrect. The highest number we can go to is a 2. This time we tried to go to a 3 and we bombed. So right there, if you ever see this, look at that number and then look at your array. If the array is set to a 3 or some number, then you can't go to that number. Remember, we start at 0. There's 3 elements. The highest we can go is 2. So another way we could get this error is if I have less than or equal to 3. That's going to get us the same exact error. So if I go to try to run this, again, I get the same exact error. Invalid subscript. I tried to go out. I tried to go beyond the number of elements in that ice cube tray. So if I take out the equal sign, as long as I stay below 3, I'm good. And now if I run this, no errors at all. Okay. So again, look for that error, invalid subscript. That's going to tell you you tried to go outside of the boundaries, the number of elements that particular array had. So in that case, we set it to 3. The subscripts are 0, 1, and 2. We tried to use the number 3. That means we're outside of the boundaries, which is actually trying to go to the 4th element. There is no 4th element, so we basically blow up. Okay, when we come back, we're going to go ahead and head on over to page 415 and look at array initialization. How can we initialize? How can we start a program and already have the array filled? So let's get back to that.